All right, we are now looking at our advanced. There's just a few new little concepts that we're going to learn for this, or really just 2 new vocabulary words. Chord, we know from before, right? A chord is a line with endpoints on a circle. Okay. So a chord goes from here right to here. That's a line there. Then secant. A secant line is a line that passes through your circle. So the biggest difference between a chord and a secant line is a secant line does not stop. It's going to continue going forever. Okay? So it's a line that just goes through the circle and keeps going forever. Then we have what we call a tangent line. And a tangent line is a line that touches the circle in exactly one spot. Okay. So here we have our tangent line, right? And it only just barely touches the circle and then continues going. Okay. So then, we're going to look at some theorems. We have angles inside a circle. That's the first of the theorems we're going to look at. Theorem 1 states, if 2 secants or chords intersect the interior of a circle, so that means if 2 secants or chords cross inside your circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Okay? So, if I'm finding the measure of angle 1 is here. Well, this side's a vertical angle, so they're the same. Alright? Then, all you're doing is adding this arc and this arc. Okay? These arcs are not the same as those angles because they're not central angles, right? But I'm adding this arc and taking the average of them. Right? Or multiplying by 1/2. So averaging those 2 arcs together. Theorem 2, which I don't know where this example 1 came from. Theorem 2, if a secant and a tangent intersect at the point on the circle. Alright, so I have a tangent line and the secant line hits where that point, we call it the point of tangency, where that tangent line hits the circle. Then the measure of each angle formed is 1/2 the measure of the intercepted arc. So for example, this angle, XTB, is 1/2 this arc. This angle is 1/2 that arc. Okay. So let's look at a bunch of examples. Find each measure. Okay, assume that segments that appear to be tangent are tangent. So if all it's saying is if it looks like it only hits in one spot, then it is. Okay. So this first one is using our first theorem. I want to find this angle. So again, the measure of... That was weird. Okay. It's going a little crazy. The measure of, this should say angle 1. I didn't like that, I guess. The measure of angle 1 equals the average, right, of the 2 arcs. So I have this arc and this arc. So 40 degrees plus 52 degrees, which equals 1/2 times 40 plus 52 is 91 degrees. 1/2 times 92 degrees is 46 degrees. Okay, so we're just plugging that in, right? This arc uses, or that angle uses those two arcs. Okay, so the next one. We're now finding arc GH. So I'm going to put my x there. I always find it easier just to use a variable. So the measure of the angle, which I know, equals 1/2 times the two arcs. Okay. So the first thing I'm going to do is get rid of the 1/2. I'm going to divide both sides by 1/2. Right? Just the opposite, 1/2 is being multiplied. So that's 90. Then I'm going to subtract 28 from both sides. So x equals 62 degrees there. Okay, so that's solving for one of the arcs instead of for the angle, which is kind of the opposite way. Number 3. Solve for angle 3, so I'm using this angle. This is a tangent line, so I got to use this arc. Number 1, it's a secant and a tangent line. The measure of the angle, which I'll just call x, equals 1/2 times whatever the measure of the arc is. So x is simply 110 degrees. Okay, so it's always half of something. This one, since two arcs are created, you're adding them together. This one, this angle really only has one arc, so you just say 1/2 times that arc. Okay. Similar for number 4, although now I'm trying to find the arc. So it's pretty much the same, just backwards, right? (74 degrees). The measure of the angle equals 1/2, right? The angle is 1/2 times the arc, which I'm going to call x. So I'm going to divide both sides by 1/2. 148 degrees is what we get there. Okay. Looking at number 5, the measure of angle 5. Ooh, this one's rough. I don't know those angles at all. What I can find is this angle, though. I'm going to call angle 5y, right? These two intersect, and I can use this one, right? So, x equals 1/2 times 90 plus 130, which equals 1/2 times 220. Right, 90 plus 130 is 220, and then I get 110 degrees. Then, what I can do next, right, is to solve for y down here. This is a straight line, right? So 110 plus y is going to give me a straight line, which is 180 degrees. Okay? So we get minus 110, minus 110, y equals 70 degrees. So this one is 2 steps. Looking at number 6 is also going to be 2 steps. Okay? I want to find this angle, and so I need to use this arc. Okay, so I kind of know both of those. What I'm going to do is I can say 160 plus y equals 360, right? If I look at where the 160 is, that's going to make up one whole circle. I'm going to subtract 160. So y equals 200 degrees. So the measure of that arc is 200 degrees. Then I can use that to solve for my x, right? X equals 1/2 times that arc. So x equals 100 degrees. Okay. All right, let's look at our next set of problems. Now we're looking at angles outside a circle. If secants and tangents intersect outside a circle, they form an angle whose measure is related to the intercepted arcs. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intersected arcs. Okay? So looking at this now, if they're outside, you subtract. That's really the only different rule. If they're inside, right, most of the time you add. Okay? So for example, this angle is this arc and this arc. I just subtract them and then multiply it by 1/2. This angle is the two arcs formed here. Again, I just subtract them instead of add. This angle is this arc minus this arc. Again, subtracting instead of adding. So it doesn't matter if they're secants or tangents. You're always just subtracting. Make sure you always do the bigger minus the smaller. Otherwise, you'll get a negative number, and that doesn't make sense. Okay. So let's look at measure of angle 1. Let's look at our first problem. I didn't like the angle symbols for some reason. So the measure of angle 1, right? So again, that's going to be our x. All I'm doing is subtracting bigger minus smaller, which is 1/2 times 40, right? 80 minus 40 is 40, which equals 20 degrees. Good. Same thing here for angle 2. X equals 1/2 times bigger minus smaller. One half times 80 is 40 degrees. All right, for number 3, it's going to be a little tricky. In order to find this angle, I need to subtract this and this. Well, these two are going to add up to 360, right? These two make a full circle. So subtract 220. 360 minus 220 is 140. For y. Now we need to solve for x. Right? Then it's just the same. X equals 1/2. 220 minus 140. 220 minus 140 is 80 degrees. Again, this is another one that's 40 degrees. Okay, so again, we're still sometimes using that those circles are 360, all of those other rules we've learned. For our last one, now it's just giving us a different piece of information. Right, now I'm finding arc JP, that's my x. So 20 equals 1/2 70 minus x. Right, we kind of got to recognize that x is going to be the smaller number there. Again, I'm going to start by dividing by 1/2. 40 equals 70 minus x. Subtract 70. Negative 30 equals negative x. Technically, there's a negative 1 there, right? So x equals 30 degrees. All right, the last thing we are going to look at is something that's going to be a little more similar to what you do in your advanced task. It's not going to be broken up problems. You're going to have one giant circle with, I think there's like 20 different things to find on it. Okay, so the first thing we want to do is find arc BC. Okay. One thing I notice is I know the inscribed angle. Remember, we're now using all of our rules. 2 times an inscribed angle, if I could spell, equals the arc. That's from be 3, right? So 2 times 30 degrees equals that arc. So the arc equals 60 degrees. And I'm going to put that here so that I can remember that. Next, arc CDB. Is going this way. Well, I'll call it X, right? Plus, this 60 is going to give me 360. So I'm going to subtract 60 from both sides. X equals 300 degrees. So that big arc is 300 degrees. Angle BOC. Well, going back to this, central equals arc. So my central angle is X, and my arc here is 60 degrees. Okay? So this one's also 60. And then BAC, it doesn't say it, but these are tangent lines. Again, anything that looks tangent probably is. But even then, we're now using that my angle equals 1/2, and I'm subtracting, right? Bigger minus smaller. Equal times 300 minus 60 is 240. So X equals 120 degrees there. So again, in your activity, which I can even pull up, right, you'll see there's lots of things to solve for. You're given a lot of things, so I'd make sure that you recognize what you were given, and then you're using anything and everything to solve for it. You can follow this order for solving the angles, but you do not have to. Okay? Go ahead, get started.